BKT has a couple different update operating modes. The most common operating mode would be in single mode. Single mode means that the user will determine when the update should happen by forcing the update or forcing the execution of the application. In auto mode and in driven mode, the update mechanism is based on some reaction in the model, similar to a KWA reaction. So let me demonstrate. Here's the BKT application. We have some attributes associated to our type. So these are the attributes that we will be overloading or changing the value of, and then those values will overload or update some parameter values that will drive a solid and a sketch. In the end, after the parameters are updated, then I have this propagate execution, which will force the cat part to do the update. So to show how you set the single, auto, and driven mode, I'll look at the sequence. On the sequence, there's an update. The update can be set to driven, auto, or single. In single mode, the user would have to specifically or manually execute the application every time they want it to update. In auto mode and driven mode, the execution can happen based on some event in the part. So let's go to our part. We have a part here. I have some parameters that are linked to the part body in the sketch via some formulas. So now we're going to apply the BKT application. And initially we do have to run the application. So now the application is live in the part and it's executed. We can continue by modifying some values here. And each time we modify the values, you can see the part is updating. So this is acting much like a reaction would act like in the part. We can do some more interesting things here. Maybe each time it updates, we want to reframe or run the fit all in process. So we'll take a look at that now. So it can go beyond the capabilities of a reaction somewhat. So in order to do this, there's a mechanism, another update mechanism called onDone behavior and onCancel behavior. So for onDone, we can monitor the status of the update. If the update was done successfully, then we can execute something else. So I will continue by adding a small VB script here under the done. Okay, so now I have my VB script implemented inside the BKT process. Let's give it some unique name. Okay, so we're calling this particular cat script, or cat VBA script. It has a module and a subroutine called main, and we have a variable that we're sending into the cat script, or the VBA script. So let's take a look at it. It's pretty basic. So this allows us to pass variables into our VB script, and you can see that I've declared some temporary variable inside the script. We're overloading it with the command in value, and then we're executing the CATIA start command. So pretty basic, but it's very generic and pretty powerful for my BKT applications. I can execute any command that I want now just by sending in a different variable, different CATIA command here. Okay. So now there's one more thing to update here. Is we need to define the done behavior. So the onDone behavior, what will we monitor in order to determine whether the fit all in should execute? Well, we want to monitor this propagate execution, and if it updates successfully, then the fit all in will run. Okay, so now we have that definition done. So again, onDone is monitoring the successful execution of propagate. If it's successful, then fit all in will run. Okay, so let's go ahead and see how it applies to our part. I'm going to reapply the application because we've made some updates. Okay, so now let's go ahead and start changing some values and see what happens here. Okay, so you can see that the update was done and then the fit all in ran. There we go. So now you can see that it's operating much like a reaction would operate. So it's updating the part and it's doing the fit all in based on the update of the cat part.